Hi, welcome to Stack 2020. I'm Jia Yi. I'm a code engineer with GovTech. Today I'm going to talk about all things smart sensors and robotics. Now, I'm part of the SNSP or Smart Nation Sensor Platform team, and what we do is we basically we do lots of really cool projects at GovTech, and we actually have a lot of projects that encompass very large scale. So what we mean by that is basically we follow this iterative cycle. First of all, we sense what's around us, we contextualize the data, and then we act upon it. This is a process that you're going to see repeat over and over again as I go through the slides. And through this cycle, we actually develop a host of different products. Now, we have a platform stack that consists of a base framework and architecture. And I'm going to go through what we're actually building. I think you'll find what we're building very exciting. Essentially, what we're doing is we have a whole host of applications and data flowing in, and then we have architectural services and products that will process this data, and then we use different IoT and sensor standards to actually make sense of it. Now, we actually talk about sensors and smart and data and robotics in the entire framework of what we call a 360-degree sensor data exchange format. So we don't actually differentiate between robots or sensors. We actually see them almost as the same thing. So we actually say a sensor is static if it's something like a thermal sensor or some infrared sensor, and then a sensor is mobile if it's a robot. Right? So these are just mobile or static sensors. And we operate on both of these. So the framework actually is flexible enough to operate on both static and mobile sensors. Now, we have three underlying themes behind our framework, and we call it the whole framework, we call it the DOS framework, which stands for the Digital Operations Smart Services Framework. First thing we do is we make sure it's remote. This means that we can actually operate our robots or our sensors remotely from anywhere in the country. We can sit comfortably in an air-conditioned office and actually operate it seamlessly. The second thing is we want to emphasize is we also work on autonomous systems, which is one of the hottest trends these days. So something like self-driving cars, but we're actually working on self-driving robots. The point of autonomy is to ensure that our robots mobile sensors actually operate 24/7. And the last thing is because it's autonomous and remote, it's also very flexible. Our framework is actually capable of working on all kinds of robots, legged robots, wheel robots, etc. So one of the very hot fields of trends these days in data is actually machine learning, especially deep learning, which is a subfield of machine learning. It's actually a way to interpret nonlinear models. So a lot of the data that comes in from the real world is nonlinear. It's not linear. It's not predictable. So the only way to make sense of these kinds of complex data is through deep learning, which is to train input data through deep neural networks, and then we run inference on it to make sense of the real world. We leverage a lot of deep learning in our field of work, in our products, especially in the realms of computer vision, and also action and scene understanding. So Spot is one of the first robots that we have incorporated into the DOS framework. Now the robot comes obviously as a base package, and then we build our entire capability robotic stack on top of the basic Boston Dynamics package. So we built a couple of features. One of them is the beyond visual line of sight, which I'll talk about in a moment. This allows us to pilot the Spot robot anywhere in Singapore over secure 4G connection. We have obviously our own SLAM algorithms to make sense of the world, to map the world, and to do any kind of waypoint autonomy. Obviously, we have a lot of deep learning-based algorithms for object detection, for image segmentation, etc. And of course, we have other features like following people and flock control and payload integration. So the first feature that we built for the DOS stack is actually the beyond visual line of sight control stack, which actually allows us, as I show you in these videos, to control the robot or pilot the robot anywhere in Singapore from, say, your air-conditioned office. So here are some examples of how we deployed the Spot robot. The first video is actually showing the robot walking at the Changi Exhibition Center during the COVID-19 quarantine phase. So it was used to actually deliver critical medical supplies to the quote-unquote red zone. So it was performing a very important task. The second one is actually we deploying the Spot robot at the parks, at one of the parks, to perform, again, COVID-19 related operations for social distancing. Now, all these robots were remotely piloted, which meant that we didn't need an operator on the ground. The operator could sit anywhere and securely and comfortably pilot the robots. The second feature, the very big feature we're also developing, is robotics autonomy. So for navigation, in large-scale outdoor unstructured environments. So this is quite different from regular robot autonomy in indoor environments. So outdoor autonomy is a much more complex and I think a much more difficult problem to tackle. And we're actually addressing this issue in the DOS stack. So the goals of the autonomy stack is 360-degree island-wide coverage, of course, 24/7 operations, and has to be very efficient and streamlined. Now, in order to achieve this, we employ a whole variety of techniques. Obviously, we leverage heavily on computer vision. We do the traditional LiDAR SLAM approaches as well, but we also more recently also leverage on the state-of-the-art techniques in deep learning. So to demonstrate our DOS autonomy stack, I think it's better to show you a video. So here I'm demonstrating 3 core features of our autonomy stack. The first one is the classical SLAM approach, where you take a LiDAR, you collect point clouds, and then you allow the dog to go localize around the environment. Now, getting a classical technique to work in an outdoor environment is quite challenging, and we've managed to tweak and customize our own code base to make it work. So you can see here, Spot is actually autonomously navigating an outdoor park type environment, going up and down the stairs. So I think that's kind of interesting and very useful. The other thing it can do as well is it can avoid humans, avoid people, avoid obstacles. So we've also put in an element of safety into our autonomy algorithm for the classical approach, which I think is very useful. Now, the other technique we have is a state-of-the-art deep learning-based approach. So this approach does not use GPS, does not use LiDAR, doesn't use radar, it uses a single camera. And with a single camera and a deep neural network and a bunch of other tricks, we actually managed to let Spot autonomously navigate also in outdoor environments. Now, what's really interesting about this approach is we don't need an expensive equipment like a LiDAR to do autonomy, which actually means you cut down the costs and lower the cost of autonomy. And it also allows you to actually navigate in places that Spot hasn't actually seen. So in this video, you can see Spot is actually walking autonomously over 2 kilometers of a park environment. And a lot of these roads, the Spot actually hasn't seen. And of course, the more data we collect, the smarter the dog becomes, so the better it is at autonomously navigating large-scale outdoor park environments. The last feature that we also have, which it will show up in a moment, is actually the ability for our robot dog to track humans. So this is not human identification, but human tracking. So what it means is it can actually track different humans in the scene, even if they're overlapping. And this is a very useful feature, especially when you need the robot to do critical operations. So the other thing that we also have for our autonomy stack is we have the ability to not only let the robot autonomously move, but you can also visualize a robot in full 3D. So this is our new C2 or command and control system for our autonomy stack. Here you can see Spot, our robot, actually navigating the premises of the office. On the left, you can see in real time what it's actually seeing through its cameras. And on the right, you can see a full 3D real-time rendered point cloud environment of the office. Now, all of these solutions, both the 3D engine and also the real-time video streaming, is all developed in-house. And I want to especially emphasize that all the processing you see right now is done on a single PC, all in real time, with some operations done on the GPU. So I think that's kind of cool. Other than autonomy, of course, the DOS framework is a very extensible framework. So other than mobile robots, we can also do static sensors. And one of the products that's come out from our stack is actually the Spot-on Smart AI Thermal Sensor. You might have read about this in the news. So this is also leveraging a lot of deep learning, computer vision, but also off-the-shelf components to make a package that's very affordable, very easily accessible, and also very, very accurate. So what it does is it allows you to actually detect up to 10 faces at once and scan the temperature of each face, each and every face, within a 0.3 to 0.5 degree Celsius accuracy, within a range of 2 meters, of course. It's not affected by masks or hats or headdresses, so that can be very useful, especially in a mass crowd environment. And it's also not affected by hot or cold items if the person is holding it in hand, because it will not be confused with it, because the deep neural network will know what to track the person's face as opposed to the person's hand. So this solution has already been deployed in many, many places, and also it's also commercialized, or the IP has been licensed to various SMEs in Singapore for further development. Now, here are some behind-the-scenes videos of Spot in development. So here on the right, you can actually see the video of the device detecting the people's faces and detecting if the person's wearing a face mask or not. At the same time, it can also detect the distances between people and also gives you a real-time temperature feedback. So this whole package is, again, developed from our core DOS framework with the emphasis on sensing, contextualizing, and then acting on the environment. So what are future plans for DOS? I've spoken about the robotic system. I've spoken about our DOS framework for smart sensors. Now we're looking at expanding or improving the spot-on AI thermal sensor package in a variety of ways. So we're looking at giving it better scene understanding and also allowing it to have features like pulse estimation, oxygen, or heart rate detection. So that's basically the extension of features we have on the spot-on front. Now on the robotic front, we're going to actually be moving our control stack over to other kinds of robots, wheeled robots, other Lego robots, drones, and even submersibles. So there's a lot of work to be done, but I think you agree that this is all very exciting stuff. And so with that, I think that ends my presentation. Thank you for coming to Stack 2020.